In this video, I'll explain about template classes. C++ programming support generic functions and generic classes. Generic functions are template functions and classes are template classes. Generic functions, I am not explaining them separately. I am explaining generic classes that include generic function also. So already I have an example class written here. First I will explain that example class. Then I'll show you what does it mean by generic, and I will convert it into a generic class. Let us look at the class. Here is a class called arithmetic and two data members a and b, integer type. Then this is a constructor. Constructor is taking two parameters. Again, the parameter names I have taken same name a and b. So these are the class members and these are the parameters. So we call this as this a or this b, and these are parameters a, b. Then I have just two simple functions for adding those two numbers and returning the result, and subtracting those two numbers and returning a result. So this is a simple arithmetic class, right? So that we can focus on the template. Now next, here I have implemented all these functions outside the class using scope resolution operator. This is the end of the class. Now if you look at this, first is a constructor, arithmetic integer ab. So ab are parameters and this ab are these ab. So to differentiate between them, now the names are same, so we have to say this caps a and this caps b, because this is a pointer to the current object, the same object. So arrow we use, this arrow a and this arrow b, this is a and this is b, and these two are parameters. Now next, this is add function, this is subtract function using class name and scope resolution. So just look at the class one. So you must be familiar with this already. In the previous video I have explained you how to write a class, everything I have explained you. This is adding and returning, this is subtracting a and b and returning. Both these functions are directly accessing the members. Now let us talk about generic classes. For understanding that, first of all, let us look at the class. This arithmetic class is performing arithmetic operation, addition and subtraction on integer type data. What about float type of data? And if I want to use long int or if I want to use double, then what? So for them, this class will not work. I have to write a separate class for it. Yes. So I should write a separate class for again floating point type of data and performing an arithmetic operation. So shall I write two different classes just for a change of data type? Though the operations are same, we will be performing same thing for addition and subtraction. Shall I write another class? No. C++ says that you can use the same class for multiple data types. At a time you can use only one data type. So it works for any type of data. So for any type of data, it is called as a generic class, and that is defined as a template. So now let us convert this class as a generic class using template. So I will just write down the code. It is just like sprinkling some code inside this one, adding something more extra to make it as generic. So how to change the existing class into a generic class? I'm explaining that one, and this is what I have followed in my course, right? I have written a class, then I made it as a generic class. Let us convert this into generic. So first of all, this class, the body of the class starts and ends here. So write down template on the top. So say template class T in angular brackets. So say class T. This is template. Now that effect of that template will start from here and ends here. So the class became template, and the variable or generic variable is T, right? Now which part you want to make it as generic? These data members. So call them as T, means no data type, generic data type. Whatever the data type you want, you can make that data type. So T can become integer, T can become float, or T can become double, anything. Now coming to this arithmetic parameters, what are these? This value will store here, this value will store here. So what is the data type of this? T. So what should be the data type of this? That also T. Okay, change it to T. This also a T. So you have to check it carefully which one will be a template. Don't write everywhere, wherever you find int as a T. Whichever should become, you have to find out that and change it. Then add, it will add two numbers, integers or float, depending on these type. So what it will return? The result. If they are integer, result will be integer. If they are float, result will be float. So this should also be t, and similarly this should also be a t. So I have made all changes that are required for making it as a template. Now next, the effect of template ends here. Now this is the body of a function. What about this? This is a constructor belonging to this class. So class is a template, so function also becomes template. So yes, write down template once again here. Why? Because this has finished here. So again write down so that it can start and end here. Start from this line and end here. So write down template class T. Template class T. Class T. So if you observe here, these I have made them as T, so these also will be T. These are template type. Template type. Now, one more thing. This class is a template class. So remember, whenever you use the class name, you should pass a template parameter. So here I am using the class name as a part of scope resolution. So here I should write down T in brackets. Then write scope resolution. This is the change you have to do. Everywhere, wherever you are using that class name, you must pass a template as parameter. Otherwise, you pass a data type. Then inside the function, there are no more changes, no changes at all. Now coming to this. See, this template has finished here. Then again, I should define a template here. So again, write template class T. Template class T. Then this class name arithmetic is a template, so it must be written like this. Then there are no parameters, leave it. What is the return type? I have changed it to T, so change it to T. Then these two are added, result is stored in C. So what should be the type of C? Same as their type, so C should also be T. Yes, this is also T. See, in my code, almost wherever I have declared data type, variable name, everything is changing to T. But it may not be true always. Remember this one. So you have to observe and change it. Whichever should be changed, only that one you change it. Now, this ends. Again, for this, I should write down a template class. Template class T. Then here, for the class, I should write T here and scope resolution, and this also I should change. So that's all. This class has changed to a template class. Now I will write down the main function. I will use this template class. So just let us write a main function. So here int main function. Now for the main function, I am creating an object of arithmetic. I will create an object name as A. Now arithmetic is a template. So which type of data members you want? Integer, float, double, which one? So here, along with the class name, I should write down the data type, int. So now this object, I will call it as AR, and I will pass the values 10, 5. Now this arithmetic class int, everywhere, wherever I have written T, that will be replaced by int, and this class becomes a pure integer class. So this works for integer type data. These variables become integer, the return types become integer, these parameters integer, everything becomes integer. Now these 10 and 5 are integer values. If I want the result, I can say cout, and I can call that function add. It will give me the integer addition of these two numbers. Now if I want a float class, then again make a object of this and give a parameter as a float, and here I will give it as AR1 and pass the parameters like 1.5 and 1.2. These are the float values. Now cout AR1 dot add, this will give me addition of these two float numbers, right? Because the parameter is float type. Here the parameter is integer type. So here the object will be integer and here it will be float. For this one, everything will become float. Wherever I have written T, that will become float. So it means the same class is working as a float also or integer also. So I don't have to write down two different classes. It works for any data type now. So whichever data type you want, you have to mention it as a template. So that's all about the template class. So you can practice this one. So I have covered all the required concept of C and C++ programming that I'm using in my course. So once you have finished this, you can start learning the course. You can start the topics of data structures. And the next section is about installation or setup required for writing C++ programs for data structures. So if you already have the setup and you are already familiar, you can skip that section and you can start with the actual topics of data structures. So that's all. I have covered all the topics that are used in my course. So if you are familiar with this, then you can smoothly understand the course. So hope you will get a lot of benefit from the course. Spend enough time on each topic and practice the programs. That's all in this video.